Going to go ahead and start rolling. Got a lot of information. We got breaks built in. And if anybody needs a break, don't hesitate to raise your hand or whatever. We got this is to be a very good class size where we can exchange information. We can be a little bit looser, if you will, and answer questions as we go along and stuff like that. So I try to keep the presentations that I do kind of more informal, if that's okay with everybody. Just as a little bit of background, my name's Johnny Vermillion, and I am a chemical engineer by training. My PE is also in engineering. Prior to starting with Spirit Environmental, which is where I am now, some of you have already mentioned or noticed my name before. I used to be on the regulatory side. I worked with the Texas Commission on the Environmental Quality, or the TCEQ, for almost 29 years, between 28 and 29 years. And so I've got a lot of governmental regulatory side experience. And then when I left the agency, I came to work with Spirit Environmental. I've been here a little over 6 years now. I'm an air program manager. I'm actually based out of Austin. And so my background primarily is chemical refining and petrochemical. And I also have done a lot of PSD and non-attainment major NSR kind of work. And so that's kind of my background. And with me is my colleague, Michelle Boss. She's out of our Houston office, and I'll let her.
Good morning, everybody. Like Johnny said, I'm out of Spirit's Houston office. My background is actually a little bit convoluted. I'm actually a geologist and geophysicist by training, but when I got out with my bachelor's in oil market. So I started a career in environmental consulting, doing soil and groundwater work and a little bit of permitting work. That slowly morphed into a career of more than 24 years in multimedia consulting, air and water based, still doing oil and groundwater due diligence type. So I have a unique perspective on a lot of the non-hardcore engineering side. And I've also had the privilege, I don't deal with a lot of the hardcore petrochemical so much, unless it's on the waste or wastewater side. But I have had the privilege of working on a lot of other variety of sources like concrete grinding plants, cement kilns, things like that that are not your typical sources that you come to expect, at least in the Gulf Coast region. Have had a lot of interesting experiences in some unique permitting situations.
She's also very, very good at SPCC water plans and things like that. And she helps us out a lot with environmental audits. So if any of you ever do air environmental audits, yeah, I should definitely keep her on that list. She is excellent in that part of the field for sure. So yeah, and I appreciate co-presenting with me today. Thank you.
Likewise.
All right, guys. So we're going to go ahead and get started. Just a few house cleaning items here. So like I said, we try to keep it kind of relaxed, informal, but at the same time, a good exchange of information. So if anybody has any questions or whatever, that don't hesitate to ask. We do have breaks and stuff built in. We know you're here for a duration. We understand that. We are too. So we get that part of it as well. All right, so we got a big menu of different things we would like to go over with y'all today. We're going to start out with things like modified versus affected. So if you're at a facility, plant site, a lot of times there's confusion, when are you modified and when are you affected and what do these mean? You may think about it when you're in passing, it's like, oh yeah, I know what modification really is. But when you're sitting there and you're looking at plans on your desk and people are coming to you with different things, and you actually start working with it, it starts to become kind of confusing sometimes. And that's because the lines do blend and merge a little bit. And so we're going to hopefully help out with some of that. Projected actuals versus potential to emit. For those of you that are in non-attainment areas or at existing major sources, Projected actuals is probably a pretty big deal to many of you now. It didn't used to be that way. 8 or 10 years ago, a lot of people kind of avoided projected actuals because it was something else they needed to track. But they're finding out over time that it is a very useful tool, especially when you're looking at triggering a major program like PSD or non-attainment. So that's we're going to go into that a little bit. My colleague Michelle is going to have a really good discussion with y'all on netting. That is probably one of the most confusing things about federal permitting for both PSD and non-attainment. They're two completely separate programs. They have their own reason to exist, but there's enough similarity between the two. It just makes it downright confusing sometimes. And so we're gonna try to separate some of that out. The next presentation after that it's a little bit more Texas centric, but it's top-down BACT versus 3-tier. If you got plants outside of Texas, you probably haven't run across this, but if you do permitting in the state of Texas, every now and then you may hear somebody talk about 3-tier versus top-down, and that discussion's a real discussion. It was a big discussion that the state of Texas had with EPA Region 6 in Dallas for a number of years there. And part of the reason you see that separation in Texas is that the TCEQ and its predecessor agencies, going back to the Texas Air Control Board. How many of you have heard that term? Yeah, Texas Air Control Board. The state of Texas actually had an environmental program before the United States did. So the TCEQ, the Air Control Board, and its forerunner, and even prior to that, it was part of the Texas Health Department. And so Texas has actually been doing air permitting of some type or another at least 4 or 5 years before the EPA ever even came into existence. And so you kind of have these legacy concepts or legacy terms. And that's kind of where 3-tier comes from. And that's why it's different than the EPA's top-down, is because it was actually developed first. And the state of Texas just didn't want to give up on that. And so there are some slight differences, but you'll find out that it all comes together at the end, and Texas does have a approvable program. We'll have a short discussion on LAER, lowest achievable emission rate. So I don't know how many of you are in non-attainment areas or major sources in non-attainment areas, but you've probably heard that there may be some reclassifications coming in the near future where Houston, Galveston, and then Dallas, Fort Worth are potentially going to be moving from the serious ozone classification, which is where they are now, to severe. And what that basically does is once you go from serious to severe, it reduces the major source thresholds. And so what's a minor source today can potentially become a major source after the reclassification occurs. And so understanding what that means and what LAER is, I think is pretty important. Right now, a lot of companies haven't had to worry about that, but we'll see how long that lasts because the EPA is threatening to reclassify both Texas non-attainment areas for the 8-hour. And then we're going to wrap up the presentation today with a little bit of air dispersion modeling and some helpful hints if you have trouble passing the National Ambient Air Quality Standards. And those potentially might get tighter in the future as well. I don't know if you've heard about it, but the EPA is actually right now doing what they call reconsiderations of the NACs. They're reevaluating the PM NACs, primarily PM 2.5, and they're reevaluating the ozone NACs. And so both of those levels may drop sometime in the future. Matter of fact, the PM probably will drop. It's just a matter of how much. So passing NACs can be a very important and critical item. So the purpose for today, this is an intermediate level course. And so we're going to presume that you have, pardon me, kind of a base working knowledge of what some of the concepts and terms are. We may go into some of them again, just as a reminder. I don't know how often some of y'all in the audience work in this world. Michelle and myself, we pretty much live in it full time. But what we do, the way I used to describe it, and the way I still describe it to some of our new engineers and younger ones at Spirit, is what we do it's a perishable asset. And you've probably found that out yourselves in your career. If you're working with something, you step away from it for a few months and you try to get back into it, something has probably changed. And so what we're going to try to do is help reinforce some of those concepts, bring you up to date on where things are, and maybe even add some new concepts that you may have not run into in the past. And so ultimately, what our goal with the class here today is just to provide a better understanding of air permitting and how some of this stuff works. Okay, sound good? All right, so let's go into modified versus affected. And so this is one of the first things that somebody is going to have to determine when they're looking at a project, or when somebody says, hey, I want to do something to a permit or a piece of equipment out there. Are we modifying it or are we affecting it? And it does make a difference in how regulatory agencies receive the project and carries the conversation when you're moving forward. And so modified is for existing facilities that undergo a physical or operational change. Now, a new piece of equipment is a new piece of equipment, right? But when you got something that's out there that's existing, you know, when do you modify it, and what is a modification? And then likewise, affected is a upstream or downstream unit that is not modified, but it has an actual increase in emissions because of something that happened somewhere else. And we're going to go into both of these categories in more detail here. So let's start out with modifications, physical and operational changes first. And so physical change is the actual construction of a facility or something physical to an existing facility. The way I describe it is you're actually putting your hands on a piece of equipment. You're doing something. You're actually physically changing part of the structure or part of how it was originally built. And so the EPA, when they came up with this definition for federal, for major NSR rules, the definition, according to the EPA and many state programs, could potentially include work that is renovation work that extends the life of the facility or the life of the project. And it's borne out in a number of things. I mean, if you think about NSPS and NESHAPs, they have levels in there where if you do changes to a piece of equipment that exceeds a certain cost, they're going to treat that piece of equipment either as a new piece of equipment, or it will now become subject to the rule where it may not have been before that. And you'll also see it parallel into state environmental agencies. For example, at the TCEQ, a lot of people don't know this, but if you're coming in with a piece of equipment and I'm going to use the word modifying, I know kind of dangerous term, but if you're doing something to it to the point where you exceed 50% of its replacement value, the TCEQ is going to consider you to be building a new one. And that's just because you have restructured what was there so much that it's like building a new piece of equipment. And so the EPA and many state programs actually take that into account, or they try to. So operational change is where it starts to get more interesting, I think, is what does that really mean? And when the EPA came up with the concept of operational change for major NSR, PST and non-attainment, they intentionally made that concept very broad because I think they were trying to encompass as many things as they possibly could and pull them into the permitting program. And so it is a broadly used term, and it's really designed where you change the method of operation of an existing piece of equipment versus how it was originally represented or authorized. And so, that's a pretty big difference is, okay, you got a piece of equipment. What did we originally tell the regulatory agency, whether it be the TCEQ or whatever state you're in or the EPA, what did we tell them we were going to build? What kind of parameters did we put on that? And then if you want to do an operational change that goes outside of that box, the EPA is going to consider that a modification, even though you haven't physically touched or laid hands on the piece of equipment. And part of the reason is that a lot of those other restrictions that go into a permit go into other things besides just the pure authorization and the technicals of what you're trying to do. It also goes into public protectiveness. If you have to do modeling, it goes into that. And I mean modeling for NAAQS compliance. And then also many states, including the state of Texas, has an air toxics program. So all of these things do cascade and build on each other. And so going back and trying to figure out, are we doing an operational change to a piece of equipment can be very important. And I've seen a lot of crazy conversations occur on whether something was modified or not. And a lot of times it gets back to operational change. And so basically an operational change can encompass a number of different things. It can result in an actual emissions increase, a change in character of emissions. And so if you're changing materials in a storage tank, you're going from product A to product B, and the tank was never authorized for product B, even though you don't need to physically change the tank to do that, that would be an operational change and therefore a modification. And again, that gets back into control technology, vapor pressure, molecular weight of the new material you're putting in. And then ultimately what the agencies exist is to protect the public. And so they'll also look at potentially at an NAAQS type analysis and then off-property impacts for health effects. And another thing is that when you represent something, a lot of representations are going to have things like firing rates, charge rates, throughput limits. All of those become conditions around which an air permit is issued. And so if you exceed any of those representations, that's also considered an operational change, which would be a modification, because you're doing something different than the piece of equipment was ever identified or authorized to be doing. And so actually operational change encompasses so much that the EPA actually decided to take the reverse course and tell you what an operational change is not. How about that? Works, and it's easier to say what it isn't and instead of what it is. And so some of these rule citations I have for you here are out of the EPA rules. You'll see two different sites, 51-165, 51-166, which I have here, and 52-21. And for those that don't totally nerd out on environmental regulations, there is a difference. And the difference is in the fine tuning of the rules. But 51-166 is the EPA's PSD rule. And that applies to states, what are called SIP-approved states. And SIP-approved states are a state that has full authority to carry out the environmental program for the EPA. And those are the states that actually issue the permits under their own stead. And the EPA is basically a third-party observer. 52-21 is a very similar rule, but it's for what they call delegated states. And a delegated state is the state basically does most of the work, but it's actually the EPA that's issuing the permit or approving the actions. So it's whose authority the activity is occurring under. That's the difference between a approved state and a delegated state. And so periodically you'll see 52-21 or 51-166 mentioned in some of the slides. That's the difference. Is 166 is for a state that has full ability to operate in that envelope. 52-21, the state does the work, but it's actually issued for the EPA under the EPA banner, if that makes any sense. And so the differences in the rule basically get not so much in the technicals, but more into the review process, who issues the authorizations and who has authority. So that's the difference between those. And so an operational change, unless the change would be prohibited by any federally enforceable permit condition that was established after January 6, 1975. And so basically, a lot of people refer to this as the grandfathering cutoff date for federal rules. And so if you existed prior to that, and operated prior to that, you existed prior to the EPA having the statutory authority to control that piece of equipment, unless it was somehow physically or operationally modified. And so in the state of Texas, for those of you that are newer to it, we no longer have grandfathering in the state of Texas. The Texas legislature actually took care of all of that for us probably 15 to 20 years ago. And so everything in Texas now needs to be authorized. There's no longer the concept of grandfathering in. But other states still do potentially have the concept of grandfathering, which is why I wanted to bring it up to you. Routine maintenance, repair, and replacement. So if you're going out there and maintaining a piece of equipment, that's not an operational change, as long as you keep the original integrity of the equipment. Now, if you take out a 500-gallon, an hour pump and you put in an 800-gallon, yeah, that's a modification all day long. But if you're just repairing the pump and stuff, that's itself not a modification. Change of ownership is not a modification. So state of Texas handles that through the alteration process. And so I've got some other things in here that I put in for just to be inclusive in the slide deck. But most of these other exemptions from the definition of operation actually go back to the late 70s and early 80s. Back at that time, there was a big embargo on the United States for fuels and petroleum fuels. The EPA and the federal government reacted to that And so there was a time when you couldn't get natural gas to fire gas plants, or you couldn't find the kind of fuel oil that you needed. There was fuel shortages all over the place, and the federal government recognized that. And so that's the reason you'll see these go to a natural gas curtailment or some kind of other policy to prevent a disruption to the American economic system and for making fuels and gases and stuff like that that we all use. And so that's what a lot of these other exemptions were for. And so, like I said, I put those in there just to be inclusive. Changes that require authorization. So if you have a production increase that requires a physical change, that's a modification. And then we already talked a little bit about operational change. And I got some more examples here. If you exceed a federally enforceable emission, basically a permit condition or representation that you make in a permit. And things like emission rates, firing rates, throughput limitations, charge rates, things like that. Those all become conditions and requirements around which an air permit was issued. And so if you go outside of that box of what you represented, that's an operational change and therefore a modification. I can't tell you how many times over my career, both with the regulatory agency and now that I'm in Spirit, the question will come up, is like, well, we're not doing that much. We recommended, we represented we're going to have a 100 ppm exit concentration, and we're only going up to 125. What's the big deal? Well, the big deal is you told everybody that it was going to be 100. And now once you go above and beyond that, that's an operational change by definition. And so it's those kind of concepts sometimes that get embroiled on your desk, on your tabletop when you're going back and saying, have I modified something or not? So just a helpful hint to kind of go back. Is it different than what you originally said it was going to be? That's huge in the environmental world. The EPA actually has a slang term they use it for that. They call that a relaxation of a federal requirement, federally enforceable requirement. And so that's the way they look at it. If you told somebody you were going to get a 99% control and comes to find out it's 98%, the EPA says you have relaxed your control technology from 99 to 98. So therefore, that's an operational change. That's a modification. The maximum allowable emission rate table. Almost always, if you have a change that causes you to have to exceed that, either a pound an hour or a ton per year, it's going to be considered a modification. Almost always. There is an exception. It's going to be an unfair exception, but we've seen that a lot, is the EPA gives themselves a lot of deference, and they treat themselves differently than everybody else sometimes. And if you haven't encountered that yet in your career, you probably will run across that eventually. So an example of that is, and this happened just fairly recently, a couple of years ago, if the EPA, say, changes a calculation methodology, AP42 storage tank calculations is a big one. They had a total revamp of AP42 a while back. And so if they did that, and you go back and you look at those new calculations, depending on the physical requirements and the materials you're using, sometimes you'll calculate an emissions increase, sometimes it'll be a decrease. It's kind of a mixed bag. But if you have something that has an emissions increase that causes you to increase the emissions on a maximum allowable table, if you're doing it because the EPA changed a factor, they won't necessarily call that a modification. Now, they may go back and make you remodel to prove that the higher emission rates isn't going to be impacting somebody off property. So there may be a modeling component to it, but they won't make you go through a full BACT analysis or something like that because it came from them. Now, what do you think happens if you go back and decide, hey, we were off on this factor a little bit. We need to go back and we're going to modify it. And, our pounds an hour, our tons a year are going to go up a little bit different. So if you talk to the EPA and to many state programs, you've increased the pound an hour on the allowable table. That's a modification all day long. So that's what I mean. They give themselves deference. They can change their factors, but the other side necessarily can't. And so just something that's kind of interesting about the world we live in. So every now and then it's frustrating. I get that. But just so you know that anytime you make a change to an allowable table that isn't directly resulting from an EPA factor change or methodology change, federal and state regulatory agencies are almost always going to consider that a modification. Okay. Any questions on Modification so far? Tracking with pretty much with what you've done and what you've heard? Good. The other category is affected. And sometimes in my career, I've noticed people will say modified and affected. They cross those terms a lot. We affected it. Well, did you modify it? Well, it's affected. Well, what does that mean? Because if you're an environmental person, modification means something different to you than affected does. And so sometimes it's just having that conversation that gets kind of interesting sometimes. And so an affected facility is a terminology that the EPA uses, and it's primarily an EPA-derived term and concept. Some states may or may not look at affected facilities. It depends on what's going on specifically. But basically, affected unit is an unmodified unit that has an increase in actual emissions because of something someplace else. So you haven't modified it. You haven't done a physical change. You're not changing the way it operates. But because of something that happens someplace else, that particular piece of equipment is going to see an emissions increase. And that's what they mean by affected units. And the EPA also has a slang for that. There's a lot of slang words and acronyms in our business, right? So they call that debottlenecked, that the facility was debottlenecked. So if you heard that, it doesn't necessarily mean it was modified. It could be. Sometimes the debottlenecked unit is the unit you're modifying to relax something. But a lot of times it's not. And we got some examples a little bit later to help point that out. And so debottlenecking is basically removing a constrainment somewhere in the system that keeps it from operating up to what you originally thought it would operate, how it was supposed to operate. A lot of you know that, when you design and build a piece of equipment, yeah, it would be nice if once you actually put it on the ground that it can do what it was advertised to do, right? How many of you have run into that before? And so a lot of times you think something is going to be able to operate at 1,000, gallons a minute or what have you. You get the equipment put out there and now it's actually doing 900 or 870. Well, if you do a change to increase it up to that 1,000, believe it or not, that's considered a modification, especially if you got the equipment built and it's already on the ground, because now you've done a physical change to it. And if you do that, and that piece of equipment now can send more to intermediate processing, it can now send more to storage tanks that those vessels have never seen before. That increase in emissions is the affected piece, because the environment is actually seeing an emissions increase. And so kind of a summary of what we were just talking about. Sources upstream and downstream primarily that experience an actual increase in emissions are considered to be debottlenecked and affected. And here's why that's important, because when you do a major NSR review, and when I say major NSR review, we're talking prevention of significant deterioration that a lot of people call PSD, or non-attainment review, to figure out if a project triggers netting, and then if the net is significant, they're looking at two categories of emissions. They're looking at modified facilities that have an increase. And so we already talked about that, right? Physical and operational changes. But it also picks up affected emission increases. Even though the piece of equipment was not specifically modified, the atmosphere is going to see an actual increase in emissions because of something that happened somewhere else. And so those have to be picked up in major NSR analysis as well. Now, the EPA, rightly or wrongly, they're going to go conservative. They're going to presume that the affected emissions increase is a direct result of that project that happened someplace else. And that those emissions increases need to be captured somehow. And that goes into determining whether you trigger PSD or non-attainment or not. Now, keep in mind that a debottleneck unit is not modified. And so the difference between those two categories, if you modify something, physical or operational change, it has to go through BACT. It has to go through the entire review process of how it works. An affected unit does not. It's not modified, so it doesn't legally and technically trigger the requirement that it has to go through a BACT review. But those emissions increases do need to get captured and included in the major NSR applicability. And then if there's any modeling, those emissions increase also need to be included in the modeling analysis. And so it's kind of part of the way there, right? So it doesn't meet BACT, but all the other criteria still generally applies to an affected piece of equipment. So modified units always undergo BACT, even if they are the unit you're debottlenecking. We've actually had people come in and say, well, the federal rules say that if I'm affecting something or debottlenecking it, I don't need to have BACT. It's like, well, that's true. Unless you're physically modifying the piece of unit that's constraining it, that gets you right back into the BACT loop again. So that actually comes up from time to time. And so not only do the emissions increases from affected units need to be included in modeling, and in applicability, don't forget there's also these other things, the air quality analysis, which may or may not be modeling. The states have different ways they can approach that, but it's a public protectiveness analysis. Somehow are you protecting the max is what a lot of that comes back to. And also if you're in a state that has increment and you have to do an increment analysis, affected facilities and the emission rates also need to get picked up and put into any increment calculations as well. And so here's the other thing about affected units that makes it confusing. They're treated almost identical to modified units. The way you do an emission increase calculation for affected unit is the same way you would for a modified unit. It's the baseline actual emission rate for that piece of equipment before the change that debottlenecked it versus either a projected actual emission rate or a potential to emit after the change. That's how they get that delta. That's how they figure out if that increase has happened or not. And that's the delta that gets put into major applicability and potentially into any health effects or modeling type scenario that would come up after that. All right, clear as mud? Any questions? Doing okay so far? I'm either really doing a good job explaining this or it's still early. I'm going to go with option number 2. It's still early. All right, modified versus affected examples. All right. So in the ozone non-attainment area, company's going to come in, they have the distillation tower and they're going to retray it with new internals and the throughput capacity is going to increase 10%. That a modification? Yeah, because you actually made a physical change. And so that automatically puts it into the modification. But keep in mind that that increase in throughput could carry over into other units. So you potentially have that affected component as well. It really depends on what those other units are, how they're piped into the overall system. They may or may not see an actual increase if it's a complex plant, complex design, but it's something that should at least be taken a look at. So if somebody ever asks you, is this affected? Did you do the analysis? You can pass the red face test and say, well, yes, it is, or no, it isn't, and why. Example 2, company in attainment area has an uncontrolled vent stream to the atmosphere, and they're going to install a flare to control that emission rate. So is that a modification? Putting on a control device. And the answer to that one is yes. It's not necessarily a modification to the unit you're controlling because the flare is reducing those VOC emissions. But the flare is a facility itself. It has byproducts of combustion, NOx, CO. If you have any sulfur in your stream, you're going to create SO2. If you have any halogens, you're going to create the inorganic acid of that. So, you may form a little bit of HCl or HBr or something like that. You'll get the inorganic byproduct of combustion. So the flare is a control device, but it's also a source of emissions. And so it's automatically something that gets reviewed. And then, yeah, the byproduct of combustion needs to be evaluated for major NSR as well. That's what makes putting on control devices somewhat interesting sometimes. And you kind of get into a catch-22. We've done a number of projects for along the ship channel, for example, at marine and barge loading facilities, where somebody will put on an oxidizer to control VOC. The VOC numbers go down by a lot, but now you got NOx that's created. So you can potentially be trading one issue for another. The agencies are normally going to say we would rather have the VOC controls, but keep in mind that NOx is also an ozone precursor. And so a lot of companies will go back and say, okay, do I want to put in a flare, or do I want to go with an incinerator or a thermal oxidizer or a regenerative oxidizer, something that helps me reduce that byproduct NOx component. So these different things kind of go into that calculus as well, if you will. But just to let you know that, yeah, all of these things are interconnected and kind of loop back around. Yes. You know, the short answer is yes, it would, because you physically changed something. Now, you can go back to a regulatory agency and try to make the argument that it's not because it's constrained someplace else. But what the agencies are worried about is if somebody comes in and does that, and then they do something someplace else and debottleneck that piece of equipment, well, it can now operate at a higher level than it could before you did the change. And they're worried about that follow-on unintended consequence, or maybe it is intended. The regulatory agencies struggle with that of, you know, when you're doing a change to a piece of equipment, what's the ultimate goal for that? And so a lot of times out of the box, they're going to come back and they're going to say, yeah, you've modified it because you made physical changes to it. And then it's just a matter of, can you convince the regulatory agency that there's really nothing to see here because I've got limitations someplace else?
Yeah, you're kind of treading the line of the ugly C word in air permitting, circumvention. So you've got to be really, really careful about those kinds of modifications. Modifier.
Right. But the default answer that people will tell you is yes, it's still considered modified. Yes. Uh-huh. Well, if you're doing RMRR, that is a capability, but in that example, where's your additional capacity coming from? That's what they're going to look at. If you have a so many barrel per day tower and you retray it with new trays and you still so many barrels per day and you're within that's probably going to be you're maintaining and you're doing maintenance to your trays. But if you retray it and now you have a capacity increase that you want to utilize, why is that and where's that coming from? That's when you kind of cross that line between RMRR and modifying, because the agencies would argue that's no longer a routine maintenance event. You've done something to increase the capacity of the tower. And that would be hard for somebody to argue against, I think. Not that you can't, but it's going to put somebody in an interesting position of trying to explain why an increase isn't an increase. That's not really a place you want to be with a regulatory agency. All right, here's another example. And I've actually, oh, yes, I'm sorry, go ahead. Uh-huh. Actually, I have not seen that very often. It's not that companies don't try, but what the environmental agencies eventually going to do is they're going to go back and say, did you have an increase in capacity? And did you have an actual increase in emissions because of that? That's what it almost always comes back to is, are you still being true to your pounds an hour and your ton a year? Are you being true to your representations as far as throughput limits and stuff like that? And are you still being protective of the public? Do you have anything that can cause an impact off-site that could affect a neighborhood or a residence or a school or something like that? And so that's the reason they go back and look at these kind of things. And so, yes, definitely the state of the art is always advancing, and that's a good thing. But it doesn't mean that just because the state of the art is advancing that you get a pass on the emission rates and the activities that you authorize. So and I see that quite a bit. Actually, this next example is going to go into a very similar situation to that. Well, maybe not exactly similar, but you'll see when I get into it. But normally, I agree with you that things do get better. But if they still go outside of the box that you originally drew, most agencies are going to come back and say, you still modify. And so here we have a source that's authorized to react A and B to create C in a fixed bed reactor. And the emissions associated with the stream, the product handling of the reactor, the feed rates, they've never reached their PTE because the reactor was actually the constraining piece of equipment. So be ready. I have a very complex process flow diagram here. So, but here what the company wants to do is they're going to modify the internals and they're going to change their catalyst to get the yield back up to where it was supposed to be. No other authorization is necessary. Their feed rates, their pumping rates, their product rates going out of the reactor, all of that remains the same. But they do have to go back and they have to change their catalysts. They got to change their catalyst bed to get up to the level that they should have had they built it the way they originally intended to build it. So is that a modification? That kind of gets back to what we were talking about earlier. Regulatory agencies are going to say yes, because you have done a physical change. And I've seen agencies do that both when I used to work for one and then now that I'm in the consulting side. I've seen agencies come back and say, if you built something and you didn't build what you told us you were going to build, you built something smaller, the agencies are going to say that's not the regulatory agency's fault. And especially if that piece of equipment has been out there on the ground for a while, they're going to go back and say, well, it hadn't been an issue for the last 5 or 6 years. Now you may.
That would be
It
helpful.
would, yes, if you have.
Email a copy of the presentation. Go ahead and put your email on the sign-up sheet, and I think there are a few of you that might have missed the sign-up sheet on the first time or second time around.
Yes, we're definitely
So,
going to share this information if you're interested. Well,
Yeah.
Yeah. And we like to keep these kind of things kind of as an open dialogue too. So even after today, if y'all have any questions or whatever. And I guess one other comment before we get started, and I'll just toss this out there to those of y'all. If this information is helpful to you and you think this would be good for your organization, we can actually do these same kind of things on site for y'all as well. So if you think this is good information, and I would like my coworkers and other people to hear some of this stuff too, definitely consider this. And yeah, we can definitely provide these kind of presentations on site or to companies virtually, however. And so they hear the same thing you're doing. I know what it's like to be the lone voice in the wind, and that can be difficult. So just FYI. If that's something you want to do, feel free to reach out to either one of us and we can help something.
I think we got just about everybody back. If y'all want to get started again. Netting. Netting is what I affectionately refer to as Aggie math. You may have heard Aggies referred to as it's hard to explain from the inside looking out. It's hard to understand from the outside looking in. Netting can be the same way. Netting is often where good projects either go to die or they rise like a phoenix from the ashes. And a lot of that all depends on how good and accurate your netting is. So some can be some very complex steps here, but I'm going to do my best to try and make them as digestible as possible. Netting is basically the applicability step to determine if major NSR has been triggered for a project. We're looking at your current project plus all creditable increases and decreases within your contemporaneous period, aka your netting window, which will vary from agency to agency. They're pretty consistent across EPA regions, but there are some variances. And the creditable is the key word. As Johnny was mentioning before, for PBRs, having that PI7 cert is absolutely crucial, because if you are claiming a PBR, if you submit a representation that, say, you've got some emissions under 261, 262. 262 is a little bit easier to prove because you're doing some very discrete emissions calculations and you're doing some health impacts comparison to the ESLs. But for 261, if you don't have that PI7 cert, they could say you're doing the full 1 pound an hour or 6 pounds an hour for certain chemicals, but you really might only be doing a 0.5 pound an hour or 2.6 pounds per hour instead of 6. But without that PI7 cert, you're going to get dinged for the whole amount when you go and you do your contemporaneous netting. So your netting is the sum of the calculation, or your net, and then you compare it against the significant emission rate for the pollutant or pollutants for your project. It is done on a pollutant by pollutant basis. So you have to take a look at all of the potential pollutants, NOx, CO, VOC. If you are emitting HCl, if you're emitting SO2, PM, all on a case by case and pollutant by pollutant basis. So you need to make sure that your calculations are top notch. And netting ensures that smaller projects do not add up to be a major modification. And that's when he came up and talked to us about the rolling boiler projects that at one of her facilities. So this is how you are trying to make sure that you are not treading into circumvention. For NOx, interesting little kicker here. It is possible to trigger netting for NOx for both PSD and non-attainment. So how is netting triggered? If your baseline actual emission rate of new or modified equipment compared to your planned emission rates are greater than the netting significant level for that pollutant or set of pollutants, netting is required. So that's where we start. And then step 2 is your actual netting calculation. As of December 24th, 2020, EPA says that your project's emissions increases and decreases can be included in step 1.
And that's the
So-
project emission accounting. that's
So,
under the-
Project emission accounting. We'll get into this a little bit more in some of the examples, but it's not that uncommon as you're taking a look at a project at your facility where you might be doing some debottlenecking in one area, but as part of that, you might either be taking some other older equipment offline or making some other possible changes where you might have some affected equipment, perhaps ratcheting down boiler rates if you're adding in a control device that does heat recovery. So you might not need some of those other sources as much. You can include those emission savings, if you will, as part of your project. And that can make or break some projects from becoming major NSR or PSD. So your baseline actual emission rate. Emissions in tons per year actually emitted during a consecutive 24-month period within either the previous 10 years, which is pretty much everybody in here, or the previous 5 years for electric utilities. It has to be a consecutive 24-month period. You can pick any 24-month period that you want within that 10 years. And it doesn't have to start January to December. You could say pick July from 2019 to June of 2021 for your emissions rate period. So if we take a look at what your baseline period would look like, it would look kind of like this. You've got a 10-year bar before your current project. And the current project start point is actually your commencement of construction. Or occasionally the TCEQ includes it as the application submittal date. So if you're doing permitting for a project that you're not planning on constructing until 2026, your 10-year period is actually going to go back to 2017 would be your 10-year window. You can't take a look and say, oh, well, 2015, 2016 was a great year. Why can't we use that? Well, if you want to move up construction to 2024, you can do that. Okay. So I got ahead of myself. Same consecutive 24-month period for all facilities emitting a particular pollutant. Now, the interesting thing is they do allow you to use a different 24-month period. Say if you're doing a flare, you're going to have VOC, you're going to have NOx, you're going to have CO, you're going to have SO2. And say for a particular period in your netting window, you had a desulfurization unit at your facility. So you were emitting lots of SO2 and you shut that unit down. You can use that 24-month period where you were operating that desulfurization unit as part of your netting window for SO2. And say you might want to take a look at your operations and use a different 24-month period for NOx and CO and VOC. Your baseline emissions might be adjusted downward to reflect any SIP requirements. This really
comes into play the most in the Houston, Galveston, severe and slash serious, all depending on which year it is. The SIP requirements that are in play. Most other areas of the state are doing okay, except San Antonio's Dallas Fort Worth is having some issues, but definitely for VOC, the San Antonio area is in the crosshairs right now. So for a new facility, like Johnny mentioned earlier, your baseline actuals are 0. For new facilities, you've been operating less than 2 years from its initial start of operation, your baseline still 0. And your baseline must be compliant. So you can't exceed a PTE or other enforceable emission limit. So we're looking at comparing to your PTE or PAE, all depending on what's available to you. Netting, it doesn't sting as much as it used to. About 20, 30 years ago, before PAE really became a thing, it was really, really popular for facilities to permit out the highest emission rates that they possibly could, saying, you know, if we run flat out 8760, this is what we can do. And that has been reeled back in between the netting process, SIP requirements. So PTE and PAE is usually a lot closer now than it used to be. It used to be we'd see facilities like surface coating facilities that would try and permit usually 70 or 80 tons per year uncontrolled or partially controlled emissions, and their PAEs were usually more along the lines of 40 or 50 tons. And they were always big losers when it came to netting, because they were definitely running nowhere near their PTE.
There was a time when having a high PTE may have been anything years ago. But in today's day and age, it's almost more of a line. Because every time you do a physical or operational change and trigger this analysis, you're going to be doing your baseline to PTE. So a lot of those companies are using projected actuals anyway. And now they have to certify their projected actuals. And one of the things that I advise is, if your PTE is that far out of range from where you're operating, consider dropping your PTE to something, and I'm going to get in trouble for saying this, but more reasonable, I guess. You know, give yourself a safety margin, but that way you don't potentially have to get back into constantly re-justifying what a projected actual emission rate is over and over. Is if you can drop your PTE down to be within a certain distance of your baseline actual emissions, that simplifies things for me. So I've heard from some people that said, you know, if they would give me 10,000 tons as the potential, I would take it. And it's kind of like, well, really? I mean, anytime you do a project or modification after that, you're always going to be compared against that higher allowable. And over a period of time, that just becomes a chore every single time. So yeah, in the day, that may have been a good thing, but now if you have a situation where your PTEs are very high, and I know that's relative, but if they're very high compared to your operations, one of the things you can softly consider is, hey, would it do us a better benefit of just lowering this PTE? Because we can't realistically utilize it anyway. And sometimes it causes more trouble than it's worth. Just that one.
Okay, significant levels. For PSD, marginal or moderate, major, non-attainment classifications for ozone. Same value is used for the major modification, the significant emission rate. And that's going to vary pollutant by pollutant. For some, like CO, it's 100 tons. It's a lot. For some, it's as little as 10. For serious and severe, it's less than or equal to 5. And some states may use any increase as a threshold to trigger netting. California, New Jersey are the top 2 for that. So if you have any facilities there, be mindful. Okay, your netting window. We're looking at 5 years from the start of construction out to the proposed start of operation. So we're going back from your proposed start of operation back 5 years. So this is where we need to be really, really certain. It's not a good word, but especially now with logistics issues, material shortage issues, things like that. A lot of you are painfully aware that construction schedules are almost double what they used to be. So you want to be mindful in taking that into account. So that can skew your netting window a little bit.
And when you do your netting calculations, the TCEQ uses a form. And on that form, it'll ask you what your estimated start of construction and start of operation. Sometimes you'll see the agency use your application submittal as the start of construction. And that really depends on the kind of project you're doing. I mean, sometimes it may take you 2 or 3 years to build something. Other times you can go in and change something out in 2 weeks and start operating. And so the agency tries not to get so definite on it to where they say, okay, you're going to start your construction cycle in 2 weeks. I mean, there it's almost easier to say, we're going to consider your start of construction when you submit your application. So that way, as soon as you get your permit, you can go out and make your changes. And if you get it done in 5 days, or if it's 3 weeks, that's fine, but you're going to have authorization for it right away. That's probably not going to make as big of a difference on your netting window as say your 2 or 3 year swing between when you actually start construction. And so those are things that go in on the application forms when you're setting this up.
Okay. So if your increases and your changes in the netting window are greater than the significant emission rate for major modifications, you trigger a major NSR. And we'll talk about EACT and modeling and all the good stuff that goes along with that. So we're comparing your baseline actual emissions rate with the PTE of the project. And like we mentioned, PTE could include if you have any emissions reductions associated with that project in addition to emissions increases. You don't use PAE for projects within the netting window. You're looking at the baseline actual, the PTE basis. There's mud.
And that concept
Okay.
is always a source of confusion. And
Yeah.
what I term regulatory tension. How's that for a good
Yeah.
governmental phrase? Regulatory tension. And so what the EPA, when they did this in their NSR reform rule, they said, okay, for the current project, you can project forward. But once that project becomes in the past, once you look at it back. The EPA argued when they wrote their rule that projections no longer matter. You know what you're doing. You don't have to project anymore. That's a historical value. And they expect companies to go back and capture that. And so when they wrote their rules, they only used projected actuals for the project that's under review at the time. And you can't go back in time and use it in your netting anymore. And there's all kinds of arguments on each side of why you should or why you should not be able to do it. We'll see if the EPA ever revises their rules and tries to take that into account somehow. But
It's really in your best interest to try and be as accurate as possible. Where this becomes really, really critical is if you're a facility that has a lot of growing pains, you're making a fair number of changes over, I say a relatively short period of time, over 5 years or so. If you do one project that, say you did a project 4 years ago that you had to do netting for, and you netted out, but let's just say, for sake of clarity, say it was a net you projected a net increase of 4 tons of VOC. You did your project. You've started operations. Say it only took you 6 months to construct. You've started operations. Your actual emissions are closer to 3. If you're using that project period in your netting window, you can take, credit for the 3 instead of the 4, which gives you a little bit more wiggle room in your netting calculations for your significance level here.
And remember me telling you that sometimes having a very high allowable can come back and bite you. This is where it primarily shows up, is once you have to look at projects in the past.
Yeah, if you said your project was going to be 4 tons and you netted out, your project actually ended up being 4.8. Still okay because you didn't trigger anything, but then when it comes to taking a look at your PAE and your baseline actuals, then you're going to have to take into account that full 4.8 instead of the 4. So unless you have a tiny project, chances are you're not going to net out. Okay. Another fun bar chart. This one, 10 years before the current project. Then we show the netting window, start of construction, start of operations. So as you're going through your netting applicability, this is how you're going to line everything out for what you're looking at. Okay. Once you have your netting results, what are you going to do with them? You take a look at the significant emission rate. Is it 100 tons? Is it 40 tons? Is it 25 tons? Is it 10 tons? Is it 5 tons? Would be on a pollutant by pollutant basis. And if your netting value equals or exceeds the significant emission rate, you're triggering major NSR. Okay, common question. Is your baseline actual emission rate and your actual emission rate the same thing? Thoughts? Who says no? Man is correct. They are not the same. Your baseline actual emission rate is your highest consecutive 24-month period out of the last 10 years. Your actual is the 24-month period immediately before your change. So keep that in mind. That's why using that BAE rate is extremely important. That gives you credit for a lot of potential operational changes. And also, as we're very, very poignantly aware, economic situations change a lot. When we have an economic recession, your production goes down. It prevents you from getting penalized for that. Okay. And netting generally is not conducted at minor sources unless you happen to be in one of those fun states like New Jersey or California, where essentially any change would trigger netting. And new major sources, basically you're in. Okay. Dilbert has a great cartoon that helps summarize netting here a little bit. How confident are you in your analysis? Very confident. Good. Unless I use the wrong discount rate, which is hard to know. But otherwise it's solid, except for the installation and maintenance costs, which are wild guesses. And we don't know if we sized the project right. So cost could be double or triple. Bless you. Sounds as if you applied math to a bunch of wild guesses. Yes, but I got the result you wanted. Next time, just say that. So, got some examples to try and help gel a little bit of this for you. Okay. Example 1, minor unnamed source in an attainment area. Your current PTE, 70 tons. Proposed PTE is 130 tons. Your baseline actuals are 70. What is your project increase? Yeah, I know it's a little early for math, isn't it? 130 tons minus 70 tons is 60.
The way I've tried to explain this is when you're doing this kind of evaluation, take where you are, your baseline emission, and where you want to be, which is your new projected or new. It's that delta.
And that's the difference. So it's, the project is a minor source and it's not a major source in and of itself. You don't trigger major NSR, but all depending on what state you're in, if they have minor NSR requirements, those might apply. So keep your head on a swivel for that. Okay. Texas specific, named major source in a Texas serious non-attainment area. Current PTE, 50 tons per year of NOx. Proposed PTE is 70. Baseline actuals is 40. We're looking at 30. You're looking at that 70 minus 40 to get 30. The significance level is 5 tons per year for the serious non-attainment area. And emission increases exceed 5 tons. So yes, you do need to do netting for this one. So we want to include all the current project emissions and creditable increases and decreases within the contemporaneous window. If you don't have either an authorized permit or a PI7 cert for it, you've got to take the hit for all of the potential increases if you authorize something under permit by rule for Texas. So for your netting, your current project is a 30 ton per year increase. We had a May 2021 project, 10 tons per year. October 2020, 20 ton per year. And a June 19, 5 tons per year. No decreases. So we're looking at 65 tons per year increase in NOx.
And this scenario is not that uncommon. I can't tell you how many times we've had a client or a potential client come back and they're worried about what their contemporaneous window is looking like. And they're telling us, you need to help me do a project where I don't trigger netting. Because if they look at everything that's in their netting window, they know they're going to be major. They've had a lot of increases and very few decreases. So it does happen probably more often than you think.
Yeah. Or they're sitting here going, what kind of controls can we use where we can get a decrease in here to try and offset? So major modification, significant emission rate for serious non-attainment areas for NOx, 25 tons per year. So it's a major modification and major NSR. So non-attainment review is required. So we're looking at layer, which Johnny's going to talk about shortly. And you're going to need to provide emission credit offsets. So your project budget just increased. Okay, clear as mud? Mm-hmm. Mm-hmm. It could have, yes.
Yes. And that's what the netting is supposed to do.
Right.
The EPA is concerned about being nickel and dime, if you will, a bunch of small projects, and then over a period of time, you've got a lot of emissions that you're not tracking.
Yeah.
And keep in mind that for these projects in the past, when they were actually the project under review, they did a very similar analysis to them. And so they went through a netting analysis back then as well. And so what the contemporaneous window is designed to do is kind of keep a running account of all those increases and decreases that happen in all of those projects within that defined limit, which the EPA defined as 5 years.
Mm-hmm. Yeah, that's where, you know, for those of you that are not familiar with circumvention is the practice where you take what could be a big project and break it up into smaller pieces to try and avoid netting review, BACT review, significant modeling and health effects review. And it's a very, very serious offense in the eyes of the EPA. They can and will shut your facility down and pull your permits to operate. at the worst, and I've actually seen that happen. Where
Or you'll have significant fines.
penalties.
And the EPA has actually done this before. No, it's been a while. And so some of you may or may not have encountered this, depending how long you've been in your position. But the EPA actually launched a formal investigation of refineries, I don't know, 8 or 10 years or so ago. And they sent out a lot of what they call Section 114 letters. And a Section 114 letter is basically a federal letter under a certain code that's basically them trying to acquire information. And they were looking specifically for companies that piecemealed projects and didn't keep a good running account of them. And so the EPA was investigating, were these companies being true to what the requirements were trying to set out, or were they trying to avoid PSD or non-attainment by subdividing projects, and it just didn't get caught at the time. And the EPA around the country found that there were multiple companies in multiple states that were doing that practice. And so the EPA would develop basically a punishment type thing, if you will, called consent decrees. And in those consent decrees, they put on additional control requirements, they put operational requirements. And some of the companies had a very hefty financial penalty just to remind them about how bad they had acted in the past, if you will. And so the refinery went through that. The EPA has also done that to select industries in the chemical. They've looked at power plants. And so every now and then they will actually pick a segment of the industry and they will go through a 114 type investigation of them. And so, yeah, like Michelle was saying, that if they think that somebody was torquing around with them, they really don't like it. You know, and there's been some big penalties because of it. So yeah, these concepts are real. They could potentially come back if you're not careful.
Especially now with the focus on environmental justice.
Yes. I think it's highlighted.
That, you know, they really, really want to see the full impacts of a project all at once, rather than seeing something nickeled and dimed and broken up into 6 different PBRs over 18 months, that sort of thing. So definitely be mindful of that. All right. So once you have a major project, you are going to be quite likely looking at BACT, best available control technology. At minimum, it will be a BACT review with your permit application for your sources, or it may be something even more detailed. If you are looking at installing new sources, they are definitely going to scrutinize, you know, are your emission controls meeting industry standards, or are you going to get a pat on the back for going above and beyond industry standards? We call this one top-down versus 3-tier BACT. Texas is now all in its lonesome. Pretty much the entire rest of the country has gone to EPA's top-down BACT. The state of Texas, as for those of you that were here earlier, when Johnny was talking about the state of Texas having air pollution control programs before the EPA ever existed, the state of Texas was essentially doing BACT before EPA was doing BACT. So they've so far retained the privilege of doing 3-tier BACT, which as we go through the slides, you'll see they're essentially, they get to the same place, but not necessarily through the same means. So we'll go through that and give you some pointers on as you're going through and evaluating your project and kind of looking at it with your glasses on of, you know, is the approving agency going to like what we are doing for backed or MACT or LAIR? So.
Interesting cultures have in some ways historically, because like I said, the state of Texas was doing air permitting reviews and DEC reviews 4 or 5 years before the EPA was even invented. And part of the reason Texas still has its own independent way of doing VACT reviews, where a lot of other states have kind of fallen in the line and top down, is think about it from the historical perspective. We've been doing something for the last 5 years. And then this new agency comes into being and says, I've never done this. I'm trying to learn how to do this. And here's how you're going to do it. And you're going to follow our methodology. How do you think that went in the halls of the Capitol in downtown Austin? Not very good. And so, yeah, for those of you that have been doing permitting in Texas for a while, if you haven't discovered this yet, it's not as prevalent as it used to be, but there's always a little bit of push-pull between the state environmental program, which is the TCEQ, and the federal environmental program, which is the EPA. And some of this tension goes all the way back to the fact that Texas was here first. It just doesn't like getting pushed around by the feds. Now, like Michelle was saying, at the end of the day, it does all come together. But there is a difference in how you get there. And that's what this slide deck is hopefully going to show. And so when you run across that, you know why. Because you do permitting in Florida or Colorado or Tennessee or something like that, you're not going to hear approved here. But if you do permitting in Texas and your permit engineer says, we followed a 3-tier procedure, just so you know what that is about.
All right. Backed. We've got a nice long definition from chapter 116 from the TCEQ. Backed is an air pollution control method for a new or modified facility that through experience and research is proven to be operational, obtainable, and capable of reducing or eliminating emissions from the facility and is considered technically practical and economically reasonable for the facility. And those are very key points. Technically practical and economically reasonable. And backed can be technology, can actually be a piece of equipment, or you can have enforceable changes in production processes, systems, methods, or work practice. So it doesn't have to be equipment. It could be limitations on throughput. It could be operational work practices. But the economically reasonable, this is really what is the fine line between backed and MACT. MACT, they're looking for controlling air toxics. The economically reasonable definitely takes a backseat to that because they want as much reduction of those pollutants as they can.
I guess the question is
How much insomnia do you have? There are anywhere from lists and white papers that indicate what typical backed is for any process under the sun. The racked backed clearinghouse that's operated by the EPA is an actual database that will tell you by process and by state for everything that's been entered into the database. I want to say it's probably lagging about 6 months or so
Depends on
for
the-
you know for what's been actually authorized by permit, but
Ideally,
you
in a
know, you
perfect
can-
world, when a state issues a permit that's in a major source, they're supposed to input that information in the EPA database. Now you're dealing, trusting on the states to do that in a timely manner, and some are much better than others.
Yeah. Yeah, so, you know, you might be at the mercy of that. But also, you know, if you know that you have a very specialized process and you know of another facility that has recently permitted that process, the beauty of the internet these days is more than likely you can find a copy of their permit and see what they got stuck with, so that either you can prepare yourself or you can pre-plan and avoid getting stuck with that yourself. So definitely use that to your advantage, or find a consultant that will use that to your advantage.
Usually
So,
the EPA kind of tries to stay in their lane. And what I mean by that is, if you're coming in with a project in a refinery, they're gonna compare you against others. If you're coming in a project in a polyethylene unit, they're gonna compare you against other polymers. So the only time they will kind of jump disciplines is if you have a piece of equipment that is inventive or so unique that there's nobody in your industry type that does that. But they might do that in another industry type. They will jump over and say, okay, how are they controlling it? And why can't you do that?
and that gets into a more complex part of the back analysis, but I do have experience with that. I'll tell you more about that in a minute. But yeah, industry by industry, equipment by equipment, and pollutant by pollutant. That's the great thing about the rack back clearinghouse is if you're just looking for controls for SO2, or if you're looking at controls for ammonia, you can do searches by those pollutants as well. So if you like going down rabbit holes, we got you covered. As you might imagine, BACT does not stand still. As technology improves, as processes improve over time, you know, I guarantee you that your chemical and refining manufacturing processes have not stayed the way that they were 20 or 30 years ago. The BACT that your facility might have been subject to 10 years ago during your last air permit renewal might not be the same if you go to make an amendment. So definitely be mindful of that. But as always, the EPA and the TCEQ are definitely interested in new technologies that lead to lower emissions or can be utilized elsewhere. So they definitely will give you every benefit of the doubt if you are looking at applying newer technologies and trying to get that in as BACT or MACT. Texas uses a 3-tiered approach. So for tier 1, your controls, whether they're a piece of equipment or whether they're operational or administrative controls, those get compared to emission reduction performance levels accepted in BACT for recent NSR permit reviews for the same process in industry. So you're only compared to with your peers. They're not going to compare a resin manufacturing category with a major surface coater or a coal-fired power plant, something like that. For tier 2, if BACT has not been established under tier 1, they'll compare your controls for similar emission streams in a different process or industry type. So for, say, if you are looking at ammonia control for a scrubber, and the particular process that you're using is different than any other chemical manufacturer in Texas, they might say, okay, well, maybe let's take a look at some electric generating units that are controlling ammonia for SCR turbines and see where you fall there. And then tier 3, final tier for Texas, is the economic evaluation. You only get to tier 3 if you exhaust tiers 1 and 2. And this is extremely rare, usually within the first 2, either comparison with your peers or comparison with similar industries. Will do the trick. EPA, so everywhere else but Texas uses the top-down approach. And it's actually a 5-step process. Here's our friend, the Rack Backler Clearinghouse. They identify all the potential control options that you have. They eliminate what's technically infeasible. They rank the remaining control options. How effective are they? They eliminate based on potential health risks, etc., what kind of emission control level you're looking at. They'll decide what's out, and then they'll select your BACT. EPA has more steps, but essentially gets to the same place that Texas does. So EPA has kindly decided to give TCEQ's 3-tier approach a pass, saying that it's equivalent to top-down, as long as you follow these 3 key points. Recently issued and approved permits within Texas. AKA, are we looking at something that's been permitted in Texas within the last year or 2? You know, they don't want you looking at BACT from 10 years ago. Recently issued approved permits in other states. You know, this goes back to is someone else in another state doing the same process or similar process, and what was their BACT that was approved? And or are your control technologies in the Rack Backler Clearinghouse? Chances are, if it was recently issued and approved in Texas or another state, it should be in the Rack Backler Clearinghouse, but might not have quite made it there yet. If you have a really, really good relationship with your permit reviewer at the agency, be it TCEQ or another state, They will often either give you a copy of a permit or tell you who's done a process and say, you know, go look at their permit and tell you where to find it. BACT isn't necessarily a self-contained process. You're looking at two parallel reviews. You're looking at not only, you know, your technology for emission control. There's a public protectiveness portion of this as well, because BACT is looking at protecting public health and the environment. So there may be air quality analysis involved. So that could be screen modeling, that could be air dispersion modeling. The agency might do that, depending on the complexity. They might request that you do that. And the choice of control technologies that they will allow for BACT can be influenced by off-property impacts. So definitely keep that in mind. What might be BACT for a facility that chose wisely and has a 20-acre chemical manufacturing facility situated on 100 acres of land that doesn't have a whole lot around it, is probably going to fare better under the property impacts than someone that has shoehorned a 20-acre chemical facility on a 25-acre property that has a lot of subdivisions and commercial development going on around it. Okay. So if your off-property impacts are not acceptable, you might be looking at further emission reductions until provable off-property impacts are achieved, or increasing the level of controls better than BACT. So you might actually find yourself in the middle ground between BACT and MAERT, even if you don't trigger BACT or controls. They're kind of trying to get the TCEQ to migrate their approach more towards the top down, since we're the last holdout. With greenhouse gas emissions, obviously control technologies that are trying to reduce greenhouse gas emissions are preferred. You know, a lot of the combustion type control technologies that were great for VOC reduction 10 years ago, but do a lot of combustion byproduct emissions are not looked at quite so favorably. And again, that's one of those things where you take a look in the racked back where clearinghouse to see what else is going on, or start looking at innovative technologies. I had the dubious honor of helping to permit the second biosorption emission control unit in Texas at a rail car cleaning facility up in the Amarillo area. Unfortunately, that one did not last, because while the biosorption control system, which is basically like a very technologically complex compost pile that had trays of bacteria that absolutely love to eat VOCs like vinyl chloride. It does require heat and steam to keep those bacteria thriving and happy. And they had a cold snap that was akin to last February's cold snap, and the biosorption system did not survive that. So other than that, it worked great. But, you know, definitely keep your mind open to what other options might be out there, but also keep the potential limitations in mind also of, you know, what's our backup plan if plan A doesn't quite work as intended. Not fast enough. They killed off the entire set of towers. So, yeah. Oops. Oops. And remember, the BACT that's approved today might be out the window 2 years from now. All right. And I'm gonna let Johnny take the wheel for a while to talk about LAIR. So what happens when you do trigger major NSR,
Non-attainment specifically.
non-attainment NSR? Does anybody need a quick break, 5-minute break? Or do you guys want to press on?
Let's get through this and then maybe we'll see.
Okay. Okay. Sounds
Because
good.
then we get into the model.
Oh, yeah.
Okay, LAER. This is one of the control technologies that people love to hate. LAER stands for lowest achievable emission rate, and it applies to new major sources and major modifications of existing major sources that trigger non-attainment review. And so LAER is by design a step and above any other control technology that is out there. Because the way the EPA realized this is, think about it this way, non-attainment review is almost a pay-to-play type system, is a way of describing it. A company is trying to expand in an area that is out of compliance, hence non-attainment. So you're basically moving in, and to be crude about it, the EPA looks at it, you're trying to expand in an area that already has air conditions that are less than healthy. You're violating the National Ambient Air Quality Standard. So if somebody wants to do that, wouldn't you expect that they would put on the best of the best? Because they're already trying to expand into an area that doesn't meet the requirements. And so that's where LAER comes from. If it wasn't for LAER and offsets, once the area becomes non-attainment, everything would freeze. You would not be allowed to add anything to it. And so there has to be some kind of mechanism, they realize, above and beyond freezing big parts of the country out from any future expansions or changes. And so what this does, it's one of the mechanisms where a company can continue to expand in an area that is out of compliance with the standard. But the expectation is they will do everything possible to minimize that impact. And so that's where this comes from. So LAER is different than any other control technology you're going to review. And again, it's only for projects that triggered non-attainment review. So it is the most stringent limitation that's contained in any state implementation plan, or it's the most stringent limitation that's ever been achieved in practice by such a source. And so most of the time, LAER is actually more stringent than what you're going to see in a state implementation plan or in a SIP. The SIPs are good in many states, but LAER many times is advanced past where the rule writing effort takes place. Because like Michelle was saying, it's a slowly advancing technology. And sometimes it takes years to write a SIP rule. And by the time the SIP rule gets approved, chances are that LAER, the state of the art, will have already eclipsed whatever that SIP analysis was. And so it's the most stringent of anything that you see in a SIP. And this is what I was talking about earlier. Unless a more stringent control has been achieved in practice, or a limitation is achieved to be, determined to be unachievable. So if it doesn't make sense, if it technically can't put on and work, it should be discounted. And it's almost embarrassing that they had to go that far and put that in there, but people are people and strange things happen sometimes. So they did try to discount that. For sure, LAER can be no less stringent than what's in any applicable NSPS, Part 61 NESHAPs or Part 63 NESHAPs, otherwise known as the MAC standards. And so it's not lowest achievable if it doesn't even rise up to what rules say you have to do. So that's kind of a catch-all that they put into it. And so LAER does take technical feasibility into account. It has to work. But the difference here is there is no economic reasonableness component with LAER. So unlike BACT, if BACT hadn't been established in an earlier project or an earlier tier, you might be able to cost out of it and say, this is not economically viable for the kind of facility I want to use. In LAER, it doesn't work that way. Because again, you're trying to expand in an area that is already out of compliance with the standard. And so there's no economic limitation. And so basically what it defaults down to is if you have a certain type of facility or certain type of operation and somebody, any place in the country has controlled it, that sets the floor. That's what you have to do. And so usually it's a specific control limit. It doesn't always have to be. LAER does include fugitive emissions. And what I mean fugitive emissions, I mean like pumps, valves, flanges, piping, stuff like that. There's actually an LAER program, LDAR, leak detection and repair program, that is the most stringent of the stringent, if you will, outside of welding everything solid. And so it's onerous by design. But again, you're coming into an area and expanding in an area that's out of compliance with the standard. Now, LAER can involve a combination of approaches, change in raw materials, process modification. Normally, it's going to be an add-on control, but not always. Excuse me. I remember one time I was working with a facility, and this has been a few years ago, but they actually used benzene as a solvent. And they were running into all kind of air toxics issues. And as you know, benzene is a carcinogen or suspected carcinogen. And there was another process that actually used cyclohexane instead of benzene. And so they actually redesigned their process to use cyclohexane and got away from the benzene. And so lowest achievable emission rate comes in all different shapes and flavors, but they're basically trying to suppress and reduce emissions as much as possible. So like we said, unlike BACT, LAER does not take economic, energy, other environmental factors into account. If somebody does it, that's what you have to put on. However, the EPA also says that LAER is not considered achievable if it is so onerous and so great that you would never build a facility to begin with. So that doesn't make a lot of sense, does it? Yeah, you can build this, but your controls are going to be so bad that you can't. And the reason they say that is because of this. If there's another operation in the same industry or a comparable industry that actually has put on that very stringent level of control, that is evidence and a demonstration that it is not cost prohibitive because somebody somewhere managed to put that level of control on and they're staying viable and they're in business. And the reason the EPA did that, and they're sharp on some of the stuff, believe it or not. When it comes to economics, what may be uneconomic for you may not be uneconomic for somebody else. And they can put it on where you may decide that's too much for me, that's too much for my company. And what the EPA would probably tell you, and what state programs would probably tell you, well, then you either need to find a way to put that control on because your peers have done it and it works. Or maybe you need to consider building your facility in an area that is not a non-attainment area. And so it is stringent and onerous by design because you're trying to build in an area that already has quote unquote unhealthy air, which is what the NAAQS is designed to protect against. And so it's a very limited case. But if you happen to fall in that limited case, it can be a very challenging and expensive undertaking to apply LAER. And it can be done. It happens, I'm going to say all the time. It's not rare. Companies do go through non-attainment review and they do go through this kind of thing. So it's not this impossible hurdle that you can never get over. But it is intentionally high because of you're trying to protect the environment. And so much like Michelle was talking about for BACT, there's very similar type things for LAER as far as the fundamental base of how do you determine what LAER is, how do you know what it is, so you can make a demonstration to your regulatory program that this is in effect the most stringent of the stringent and should be accepted. And so first what they're going to do is they're going to look at recent control technologies in your state. They're going to look at recently approved control technologies in other states. They want to make sure you're not operating in a silo. And sometimes they'll actually expand that into other territories as well. We had a scenario come up not too long ago where there was actually a company that was doing an innovative control that worked in Puerto Rico. And so that's set. So don't internalize states as to the 50 states. It applies to all American controlled territories also. Puerto Rico is the most common. Every now and then you'll get a hit out of the Virgin Islands, but that's really where it comes from. And then they'll also go back and they'll look at control technologies contained in the Reapplicability Clearinghouse or RBLC. That's really the first place people probably go, is they'll do an RBLC search. Then they'll go to the state they're in and try to search as much as they can in information available electronically, or potentially go to their file room and ask for, can I see permits of a certain type of a certain industry class issued within the last 5 years? And then they'll go through and then it becomes data mining, but it's a necessary evil for some of these things. And then always compare to the SIP level. There's probably not too much more embarrassing if you say this is the most I can do, and there's a Part 63 max standard that requires something more stringent than that. That's kind of hard to explain to management when that happens. And so the RBLC, Reapplicability Clearinghouse, and Michelle touched on this a little bit. So what is it? It's basically an EPA database. It currently contains about 5,000 controlled determinations in it. And that's slowly expanding as more and more permits at major sources are being developed. They have information for over 200 pollutants and 1,000 industrial processes. And so unless you really have something that's kind of a off the wall or truly unique or something, odds are there's going to be something either directly like your unit or similar to your unit where a demonstration has already been made. These are searchable. It's on the EPA's website, Control Technology, Clean Air Technology Center. So if you look for that TTN or Clean Air Technology Center, that should take you to it. And it's searchable in a variety of different ways. The 3 most common is you can look for facility type. So, I'm a reactor, or I'm a flare, or I'm a polyethylene unit, or what have you. Process data, you can put in, I'm over so many, million pounds of product or so many thousand barrels a day or something like that. And then by pollutant data, you can put in a general search and say, I want to see everything that anybody's ever done for NOx. And what most companies do is they'll actually run a search routine using all 3 parameters, and then they'll cross compare and see if they can isolate what the most stringent one is. And that's what actually sets the floor. And then if you want to build it in that non-attainment area and you triggered non-attainment review, that's going to be the value you're going to be expected to meet. And like I said, by definition, it's intended to be stringent. So that's kind of what LAER is. It's the best of the best as far as controls that's out there. And it, like BACT, it slowly advances, probably not as fast, but it does advance. So anytime somebody triggers non-attainment, they'll go back and they'll do an RBLC search just to double check. What's interesting about it is if any of you have dealt with a non-attainment review, LAER is just one of the components. The other components is you have to offset the project, which means you have to purchase actual emission reductions greater than your potential emission increase. And those emission reductions can become very, very expensive. Sometimes, and it varies. Texas has an emissions banking and trading program, and there's 2 or 3 emissions brokers. That's actually what they do, is they identify emission reductions for non-attainment permits. And the last I checked, and it fluctuates. It's kind of like playing the stock market, if you will. But the last time I looked, which was a few months ago, for VOC and NOx, they were running on the order of somewhere about $175,000 a ton, up to north of $210,000 a ton. And if you have a 50, 60, 70 ton project, you know, a few hundred there, a few hundred, you know, the old saying is pretty soon you're talking real money. And so not only do you have to put on the most stringent control technologies, you have to buy and spend all the money for offsets. Well, the reason the RBLC is important, and you don't want to look at just other non-attainment permits, there are companies that will come in and they will put on innovative, and very stringent control technologies above and beyond BACT, and sometimes surpassing previous levels of NSR. So they net out and don't trigger the offset component and don't have to buy all of those offsets. So to some extent, there's actually a feedback loop on LAER that goes above and beyond just strictly looking at other non-attainment permits. That's actually what drives a lot of the LAER advancements, is company trying to avoid it. I'm just curious, how many times has a manager, somebody comes in and said, there's this project, but we can't trigger non-attainment. Whatever you do, do not trigger non-attainment, or it kills the project. I've actually had clients come in and say that's the marching orders that they were giving that they're operating under. And the same thing when I used to be on the regulatory side. Companies would come in and try to get a permit, and they're like, you know, Johnny, you need to help me. I'm doing the best I can, but I can't trigger non-attainment. You know, otherwise there's going to be heck to pay back at the office if something happens. And so then you end up going back and looking at all these innovative controls and seeing what's out there. And so that's part of the reason why. So LAER, there are people that will go beyond LAER to avoid formally having to install it, if that makes any sense. And the reason they're doing that is they don't want to purchase the $4, $5, $6 million worth of offsets that they might have to do as well. And so, yeah, that kind of drives the technology along. So yeah, that's kind of my my little spiel on LAER. Any questions, anything like that before we move into the next? So when somebody comes up and says, that's LAER, that's just stupid stringent. Yeah, by design, that's the way it was supposed to be. Understand why it is that way, you know, non-attainment versus attainment areas, because they're actually trying to protect against the max. Otherwise, like I said before, everything would freeze, and that's probably not to the benefit of any of us if that happens. Okay, I've got 10 after 11. Do you need a 5-minute break? Because the next thing we're going to be moving into is modeling and max analysis and stuff like that. So we're kind of leaving the control technology, the formal applicability analysis, and entering more of once you got your permit and you have to demonstrate public protectiveness, now what happens once you enter that phase? Y'all want a 5-minute break, or do y'all want to keep trudging forward? 5 minutes? Okay. Although either one of them.
What time is your break?
Ready? All right, guys, I think we're gonna go ahead and get started with this last unit so we can wrap it up and
Get it all wrapped up. If you have any questions. All right. I am going to qualify this with, I am not an air dispersion modeler per se. We employ several experts. One is a fantastic modeler and air permitting specialist, and another that is actually a certified consulting meteorologist that does a lot of the heavy lifting. But we've included this to give you some flavor of things that you're going to run into. You know, if you really want to get heavy duty into air dispersion modeling, there are 4 or 5 day long courses that will make your eyes and ears bleed. I have at least one in the room that knows that drill. But we're going to run through some very, very critical concepts that as you're going through your permitting exercises, that these are important things to know so that you can understand how they're going to affect your projects, and also so that you can understand, you know, if you have a good modeler, you can help guide the conversation as well as they can. If you have a not so good modeler, you can call BS on them. Or you're getting your money's worth. Or go find a good modeler. Requirements to model for health effects impacts analysis. They will vary by state and will vary by permitting action. You can have basically just screening level modeling, or you may have heavy duty full air dispersion modeling. As a very basic requirement, agencies will require modeling for PSD, major NSR actions, non-attainment, and the air dispersion modeling results are used to demonstrate compliance with NAAQS and PSD increment standards, and sometimes very specific air toxics. Some states like Texas and New Mexico require modeling to demonstrate compliance with state health standards that are also different from federal NAAQS or property line. And you could be required to do this for minor NSR as well. So you've been requested to do modeling. What do you need? A lot. Source input data, you know, where are your sources? What are your emission rates? Stack height, stack diameter, temperature, exit velocity, and fugitive sources. Fugitive sources can actually cause more problems than point sources. Your site location, property line can be very, very critical. If you've got sources that are very close to a property line, that causes major issues on occasion, especially if you've got some critical receptors like residential areas, daycare, schools, that sort of thing nearby. And sometimes looking at doing a combined property line with an adjacent facility is a good idea. Building structure, dimension, and location data, and making sure that that's accurate. You would be surprised at, you know, what 5 or 10 feet of difference can do with your modeling results. Meteorological data. Sometimes this is provided by a state agency or a regulatory agency. Sometimes you have to ferret this out yourself or have your modeler do that. And elevation data. So SILs, significant impact levels. What's a SIL? It's officially defined as a reference air concentration that is used to determine if a new or modified source causes or contributes to a violation of a modeled standard. And there are 2 types of SILs. There's a class 1 and a class 2. Sills are used as screening thresholds and modeling. We're looking at max and increment levels. To determine if your project requires additional site-wide modeling. So this is the gatekeeper. So we're looking at modeling project emission changes and comparing offsite impacts and the changes to the sill. If your impacts are below the sill, you're done. You don't need to do anything else. If you exceed the sill, the project is considered significant with respect to modeling. You bounce from screening modeling to site-wide modeling. And we're looking at a defined area of impact. So what are these sill creatures? We are looking at different pollutants have different significant impact levels. And it is dependent on the air quality of the area in question. So whether or not you're meeting the air quality standards, as Johnny was mentioning in the last section, the pay to play. If your pay to play area is already hurting, your significant impact levels are going to be typically lower. And you typically have different averaging times that you're looking at, like 1 hour, 8 hour, as opposed to 24-hour or annual. So as you can see by the chart, there are several that just have 1 hour, 8 hour. Some are 24-hour and annual. Some are 1 hour, 8 hour, etc. So what do we do if our project impacts are significant? You take a look at your project emissions. Is there something that you can massage a little bit here or there? Maybe add in some operational controls or administrative controls to tweak that a little bit. Maybe do a limitation on a pumping rate, a tank filling rate, a loading rate. Can you refine your modeling inputs a little bit? Maybe look at that combined property line designation. And if that doesn't work, then we look at full-on site-wide modeling. All right. When we're doing a full NAAQS analysis, we're looking at all emissions, all sources for NAAQS pollutants. And that goes out to within 50 kilometers of your source area, your area of interest. So we're not looking at just your facility unless it's an exceedingly large facility. You're looking at all of your neighbors in addition to you and what they're emitting. And you're typically looking at background concentrations from an ambient air monitor in the area if one exists. And then we're going to compare your modeled impacts and your background concentrations with the NAAQS to see where you fall. As you might expect, when you're taking a look at that 50-kilometer area, If it's a very, very densely developed area, a lot of facilities, as you might expect, it can be very, very time consuming and expensive in evaluating all that data. So in addition to worrying about air emissions credits and layer, your modeling can get very expensive as well. Some states don't require the inclusion of offsite sources. They'll just take a look at the background monitoring data. That's probably about half the country. Okay. Representative monitoring sites for ambient air monitors could be your very own monitor. When we were talking about the consent decrees earlier that Johnny mentioned, some facilities as part of consent decrees have installed on-site monitors at their facility, or you might have a neighbor that has an ambient air quality monitor. You can get data from those. You can use an ambient monitor in an area that is similar to the site within reason. Typically, if you go more than about 200 to 300 kilometers-ish from your site, that can kind of be frowned upon unless you can prove that the facilities in the area that you're using are very, very pollutant similar to your operations. If you're going from an area where, say you're in an area where the pollutants emitted are a lot of VOCs, and you're comparing it to an area where there's a lot of NOx and CO, that will not pass muster.
The terminology they use, it has to be representative. Kind of nebulous, I know, but they're trying to find something that is close to you as they can possibly get.
You will be requested in most cases to do a NAAQS evaluation for ozone and PM 2.5 unless you're not emitting PM 2.5 sources at all. But at least for the chemical and refining industry, that you're probably going to be emitting some VOCs that are ozone precursors and some PM emissions. Things to consider is the ozone and PM 2.5 may not be directly emitted from your sources, but might be generated from primary emissions of other pollutants. And you have to quantify the impacts from those secondary formation. So what do you do if your proposed project exceeds the NAAQS? And this does happen a bit, actually, especially in Texas. This is more out of going back to policy memos. You won't find this really in a guidance document. You can use a ratioing approach that they refer to as the ambient ratio method 2 or ARM2 approach. And it uses an EPA equation to basically ratio down your NOx impacts.
Because even though people talk about NOx as being what's under evaluation, the National Ambient Air Quality Standard is actually NO2. And so you have NO3, you have other kind of byproduct cats and dogs. And so it's a way of taking your total NOx and then figuring out how much of it is actually target pollution and adjusting it.
Using tier 3 approach, this one relies more on input of in-stack NO2 to NOx ratios, and also looks at the background ozone concentration data. A little bit more convoluted approach, and can be somewhat time consuming. Other pollutants, PM 2.5, carbon monoxide, and SO2. Looking at averaging emissions that don't regularly occur in the time frame of the standard. You can do that, especially as unless you are running 24/7, 365. Your emissions are definitely going to vary. And you may have greater daytime impacts based on actual operations, but usually your air quality impacts are worse in the middle of the night when things are calmer. We can use intermittent source guidance. Depending on development, you can look at running urban versus rural dispersion options. If you're in a heavily developed industrialized area, definitely a no-go for the rural dispersion option. But if you're in an area where it might be iffy, you can talk with the modeling contacts at the regulatory agency and see what they're willing to accept. This one is actually more common than you might think. A lot of state agencies will provide you with very, very generic provided data sets. If you're lucky, it might get kind of grouped by cities or regions. But pretty much just about every airport now has its own monitoring station. So if you can either get meteorological information from an airport monitoring station or a local monitor, you can use that data. And the closer it is to your site, the better off you'll be for using that data for simulating conditions on what might occur. You can look at doing a culpability analysis. You can look at operational restrictions. Play around with stack heights. Higher stacks, better dispersion. Greater stack velocity, greater dispersion. So there's a lot of stuff that goes along with stack heights that modelers will play around with. Can you relocate the source? Can we ratio things? Again, NOx, PM. Is your property or fence line represented correctly? Have you been working off of a plot plan that is 50 years old as opposed to an actual site survey? Sometimes that can work to your benefit. And sometimes if your survey is off and your plot plan does not jive with your survey, that one can actually backfire. So definitely use caution with that one, and definitely understand where your fence line, property line is with representation to your property survey. Again, if you can do a combined property line with a neighboring facility. Sometimes that helps a lot for both of you. And background monitors, definitely know if background monitors are available nearby. Can help a lot. Questions? Is your brain full yet? Ready for lunch?